For CLO1, the algorithm of this machine is going to be explained using a flowchart. It starts off with an empty graph and the sensor that checks the voltage of the soil. If it's greater than 3.4, the soil is dry and the pump is on. If it's less than 3.4, it checks between 3.4 and 2.8. If it's between, then the soil is somewhat wet, but the pump is still on. If no, the soil is fully wet and the pump is turned off. All of these lead to updating a live graph and a pause after. For CLO2, the main procedural programming constructs used are loops, conditionals, and decision structures. We have a while loop up here and if-else statements down here for 3 different states of the plant. For CLO3, I made two different functions. The first being an equation that converts the value of the sensor into a normalized value, and it scales between 0 and 1, where 1 is dry and 0 is wet. The second function creates the graph by plotting the information on the x and y and inserts labels and a title. For CLO4, as explained with the function before, the mathematical modeling of the equation changes the values to normalized values, which are updated in the while loop and displayed in the command window. As well as the state machine has 3 conditions: fully dry, somewhat dry, and fully wet. So as you can see, the plant has been watered, and then if we look over here, so it starts above like 3.4, and then it dips down to below the threshold, the dry value, sorry, the moist value, and then it maintains a steady trend. And then if we go over here, we can see that it starts off with soil is wet but not too wet. It shows the normalized value, and then after it allows 2 pumps, it says that soil saturated, turning off pump, and then it just keeps on going. How it works: this is a bowl of water, the pump is submerged, we have a tube connected, and it leads into the plant. This is the sensor that's connected into our pin, which is A0. We have the MOSFET that connects the pump as well as the battery into the pin of D2, and then I have my